Hi everyone. Here's a video on grouped frequency distribution tables, a little bit of vocabulary for you. This should help you with some of the questions on Module 1. And so the first thing we're going to do is hopefully you've already watched the previous video on frequency tables and histograms. I'm going to use the same data coming up, but the first thing I want to show you is, let's say we're looking at some test scores. Okay, the first thing, this is a typical, what looks like a typical frequency distribution table. However, what we're going to notice is that the class widths are not the same. So for example, your test score in this first class is right here. Yeah, here we go. Is from 40 to 59. And the next class width, the next class is 60 to 75. Now that we have 2 people in that first class and 4 people in the second. But it doesn't actually have that much meaning, because look at this first class. The class width has to do from the lower class boundary of one class to the next lower class boundary. These are the upper class boundaries, okay, or endpoints actually I should say. So if we take 60 and subtract 40, we get 20. This class width is 20, this first one. However, notice that the next one goes from 76 to 82, and this one went from 60 to 75. Well, what is the distance from 60 to 76? That's actually 16. All right, so there's 16 different test scores in this second one and only 10 in the first one. So it doesn't make any sense. This becomes kind of a meaningless. This is actually not a frequency table, a frequency distribution table. Okay, it can only be a frequency distribution table if it has equal class widths. Okay, let's go up here. So this is actually the data from a previous, from the previous video that I put up. We were looking at test scores, and in the previous video, we were given the raw data of test scores. Let's see where I'm here now. We were given the actual raw data of all the different students in the class. I think there were 60 of them, and you can go watch that video if you want the actual number. And we created a frequency table. We just literally counted them up. There was one student who had a test score between 40 and 49. There were 5 students that were between 50 and 59, and so on. So we know also from the previous video that the class width for this one, there should be a single class width for a frequency distribution table. There's only one, because every class is the same distance. So this goes from 40 to 50, which is 10. This goes from 50 to 60, which is 10. So lower boundary to lower boundary. You could do upper boundary to upper boundary. It doesn't matter. Subtract 59 minus 49 is also 10. Okay, so our class width is 10. That's the definition of class width. All right, one of the other things we're going to look at, or we probably heard talked about, is something called, keep this one on. Sorry. All right, I'm going up one second. It's been a while since I made a video. Here we go. Cumulative frequency. What is cumulative frequency? Well, the cumulative frequency is just how many people in each group plus the one previous to that. So, for example, this one here, the cumulative frequency for this first class, 40 to 49, there's one student in there. And in the next one, 50 to 59, so what it really means is how many students are below 59. How many students got a test score below 59? Well, that's going to be these 5 people in the 50 to 59 plus this one in 40 to 49. So we actually have 6 students altogether that are below 59. How many students are below 69? How many students got below a 69? Well, we know there's 6 below 59 plus another 16 here in 60 to 69. So we're going to add the 6 to the 16 and we will get 22. So in other words, there are 22 students with a score below 69. 22 plus the 25 in the next class is going to bring us to 47. And don't hesitate to use your calculator. You don't have to be expected to do this in your head. There's going to be 57 students who got below an 89, and 57 plus this final 3 will be 60. Now notice that this number here is the same as this number down here, because that's how many students, that way back up here there were 60 students, 60 test scores. All right. So all 60 students were below a 99. And why would you want to look at cumulative frequency? Well, maybe you want to get a sense of how many students failed. Okay, let's say in this particular class test, anything below a 70 is a fail. So that's going to be these 22 students here. You know you've got 22 students who failed the test or got a D or an F, something like that. So it's just another piece of data for us to look at. Okay, let's go to layer 5, 6. Okay, one of the other ones you're going to see is relative frequency. Relative means percent. Okay, relative frequency. In other words, what percent are in each of these classes? Right, well, hopefully most of you remember how to find percentages. We had one person out of a class of 60 who got a 40 to 49. We don't. And if you do that on your calculator, 1 divided by 60, it's going to be 0.0177. And we're going to round roughly. It's 1.7%, but just for simplicity, I'm going to say that's about 2%. Okay, so 2% of the class got a 40 to 49. Okay, the next one, what is the relative frequency for the next set, for the next class? Well, 5 people out of the 60 got between a 50 and a 59, and if you do that on your calculator, it's going to be about 8%. It's 8.3%. And so using our rules of rounding, we're going to round down. 16 in the next class out of 60. Do that on your calculator. 16 divided by 60, we should get approximately 27%. And working our way down, this is going to be about 42%, 17%, and 5%. All right. And if you sum up all these percentages, what should we get? We should get approximately 100%. Now, if you get 100 over 101 or 99, that's fine. It's just because it's because of the rounding pieces. But yeah, so because 100% of your students or all 60 of your students are below 99. All right, so that is the definition of relative frequency versus cumulative frequency versus regular frequency. Okay, we've talked about our class widths. All right, in this next one we're going to look at, we're going to go to here. And lastly, you might be asked for the midpoints. The midpoint is just that center point. What is that test score in the middle of this class, the halfway point? And maybe some of you remember how to find halfway points. So the midpoint for this first class, let me take a little different color here just so we can see. So let's say we're going to add 40 plus 49 divided by 2. You can do that on your calculator. 89 divided by 2. And on your calculator, that's going to equal 44.5. That is the halfway point in that class. And maybe you want to know that number to see, for some sort of sense, once you have it in a histogram, what are those midpoints? And how many are above it, how many are below it. Maybe there's, even though there's, go to this one, 50 to 59. Again, if you do the same thing, you're going to find the midpoint is 54.5. But in fact, you've 5 people in this group. Maybe you had 4 of them were 50s and 1 was a 52. So you actually see, even though there's 5 people in this whole big class, they're really actually below the midpoint. So you might draw the midpoint in the histogram to get a sense of what's going on there. All right, continue on, and this will be 64.5, 74.5, 84.5, and 94.5. Those are our midpoints. And then the last thing you could be asked are, what are your class boundaries? I believe we talked about that in the last video. Let me just write this down. Class boundaries. Okay, what are they? Well, when you go to the histogram, it's that boundary, it's that line between one class and the next class. Okay, so if this class ends at 49 and this one starts at 50, what is that? What is the line that divides those two if they're going to abut right up next to each other? And again, we can use the same idea. What's halfway between something? You add them together. 49 plus 50 divided by 2, and most of you can probably guess what that is. It's going to be 49.5. It's halfway between 49 and 50. So our class boundary is 49. That first class boundary is 49.5. The next class boundary would be between 59 and 60. So it would be 59.5. The next one would be between 69 and 79, which would be 69.5. And so on. I'll let you finish that up. The last one would be at the end, 99.5. And oftentimes you will see in the front end where your histogram starts, here's a 40, that's your bottom number. So the actual boundary up to that would be the 39.5. Okay, so here's some all the different parts of a very big grouped frequency distribution table. On the homework, you might see it as the acronym GFDT. For the most part, we're just looking, this is what we sort of look at, the test score or whatever your topic is, and the frequency of that. That's a frequency table. This is just additional types of data that you can look at within that. All right, so hopefully that helps with some of your homework, and good luck.